Alright, here is 3.8 derivatives of inverse trig functions and derivatives of inverses. So suppose y equals the inverse sine of x. Find dy dx using implicit differentiation. Well, I don't know how to find the derivative of inverse sine yet. I could look down there, but I want to show you where it comes from. So what I'm going to do is I'm going to uninverse it. So how do you get rid of inverse sine? You take the sine of both sides. So I have sine of y equals x. Now that will be cosine of y times dy dx equals 1. If I solve for dy dx, I get 1 over cosine of y, 1 over cosine of y. So dy dx actually equals secant of y. Well, how does that help us? Well, let's go back to sine of y equals x. Now what that is if you remember from last year, if we look at a triangle, sine of y is my angle, equals, this is opposite, adjacent, and hypotenuse. So sine of y equals x. Sine is opposite over hypotenuse. So sine of y equals x over 1. So that's my opposite and that's my hypotenuse. And if I solve for the other side using the Pythagorean theorem, I would get the square root of 1 minus x squared. Because if I said x squared plus, I don't know, squared equals 1, and I moved it over and I took the square root, I would get that it's 1 minus x squared, the square root. So now I want secant of y. Well, what is secant of y? Remember, secant is the reciprocal of cosine. Well, cosine is the adjacent over the hypotenuse. So that's the square root of 1 minus x squared over 1. So what it ends up being is 1 over the square root of 1 minus x squared. You could go through and find them all of your inverse trig functions, and this is what you would get. Good news, if nothing I just did make any sense, you don't need it. It was just showing you why you're using u's and x's and stuff when they're inside. And when you see sine inverse and arc sine, those are interchangeable. They're the same thing. Yes, unfortunately, you do have to memorize these. Sine inverse, inverse sine, inverse tan, inverse cosine come up all the time. Cotan, cosecant, secant, rarely. Very, very, very rarely. So I'm going to make you memorize inverse sine, inverse tan, and inverse cosine immediately. So here we go. It's find the derivative of inverse sine of t squared. Now this is a chain rule. The derivative of inverse sine is, it says inverse sine of u, and it actually accounts for the chain rule. It's really just 1 over the square root of 1 minus u squared, but then you got to do times the derivative of the inside. The derivative of the inside. No, I'm lying. It's u prime. Yeah. The derivative of the inside is whatever the derivative is. So that's the chain rule. So it's u prime 2t over the square root of 1 minus u, which is t squared, squared. So you would end up with 2t over the square root of 1 minus t to the fourth. Now the thing about these is these are very easy, but you have to memorize them first. So that's the part that kind of sucks. Example 3, and I apologize if you can't tell, I'm extremely tired. It is Friday at 4:51 p.m. and I'm making a video. Find the derivative of y equals inverse tan of the square root of x minus 1. The inverse tan derivative, and I'm just pulling this from above, equals u prime over 1 plus u squared. Well, above being on your paper, not above, like there's nothing above what I'm looking at right now. So I need to find my u. My u is the square root of x minus 1. And my u prime is, let's see, that'll be x minus 1 to the 1 half. So 1 half x minus 1 to the negative 1 half. Yeah, that's all. So it's u prime 1 half x minus 1 to the negative 1 half over 1 plus x minus square root of x minus 1 squared. So if I simplify that, that's 1 half x minus 1 to the negative 1 half over 1 plus x minus 1. The 1's cancel out, and I can move the 2 and the square root to the bottom, and it's going to give me 1 over 2 x square root of x minus 1. Because remember, the 1 half is the square root, the negative moves to the bottom. Okay, derivatives of other inverse functions. Now this comes up a good bit on AP, and for whatever reason, like every book just completely leaves it out. So here we go. Graph the line y equals 4x plus 1. Okay, I can do that. Up 4 over 1, 1, 2, 3, 4 over 1. Down 4, 1, 2, 3, 4 over 1, 1, 2, 3, 4 over 1. So there's the line. Find the inverse. How do you find the inverse? You swap x and y and solve for y. So x equals 4. Oh wait, what is the slope of the line? I'm just kidding. 4. Find the inverse function. X equals 4y plus 1. So it'll be y equals x minus 1 over 4, or 1/4 x minus 1/4. So up 1 over 4, up 1 over 4, down 1, left 4, down 1, left 4. Okay. So, what is the slope of the inverse function? Well, it's 1/4. It's the reciprocal. It says if 2, 9 is on the original line, what point does it correspond to on the inverse? Well, 9, 2, because you swap x and y. So it says the slope of the line at 2, 9 on the original function is the reciprocal of the slope of the inverse. The difference is that the slope of the inverse is calculated using the point 9, 2 instead of 2, 9. So the coordinates are reversed. So, it says we have a different notation used to describe the derivative of f at the point x equals a. We can write df dx at a. What all that means is the derivative of f with respect to x at x equals a. It says using the concept from the last example, we can find the derivative of the inverse function without actually finding the inverse function. We will use the notation above to describe the relationship. Derivative of the inverse function at a point PQ. This implies that point QP is on the original function. To find the derivative of the inverse at the point PQ, we find the reciprocal of the derivative of f at the point QP. I would be willing to bet you have no idea what I just said. What you do is it's 1 over the derivative of f at the point where f of x equals y. Oh, I bet that didn't make any sense. Okay, let's keep going. At the, hold on. Let me write that another way. At the, y value where, no. Let me just show you, and then we'll determine it, because I'm having a hard time with that. I'll come back with that in a second. Alright, it says let f of x equals x to the 5th plus 2x minus 1. Verify 0, negative 1 is on the graph. So 0 to the 5th plus 2 times 0 minus 1 is negative 1. So it says find the inverse derivative at negative 1. What it is it's 1 over the derivative of f at 0. So how can I say that? If they give you Alright, this is what you do. Step 1. Usually they just give you this and they don't give you that part. You set the equation equal to the point they give you. Then do 1 over the derivative at the x value you just solved for. So if they had not given me that 0 right there, and they just said f inverse prime of -1, I would have set x to the 5th plus 2x minus 1 equal to -1, solved for x, got 0, and then plugged it in right here. So what we do is we do 1 over the derivative, 5x to the 4th plus 2, and we plug in 0. 1 over 5 times 0 to the 4th plus 2, and my inverse derivative is 1/2. And you're probably still like, what? This is kind of a hard concept. Hold on. Let's do another one. Example 6. Let f of x equals x cubed plus 2x minus 1. Find the derivative of the inverse at 2. So what you do is you set this equal to 2. And usually these are on the calculator part because you're going to have to actually solve that on your calculator. So I'm going to cheat because I'm tired. I'm ready to go home. Menu algebra solve. X to the 3rd. Come on. Plus 2x. I'm using my finger instead of my mouse because I feel like I'm getting carpal tunnel from having to use my stinking mouse. I'm not kidding, I really am. Comma x. Dang it. Comma x. Enter. X equals 1. So what I'm going to do is I'm going to do 1 over the derivative of f. So 3x squared plus 2, and I fill in 1. 1 over 3 times 1 squared plus 2, 1/5. Ta-da. Oh, look, worksheet 3.8. Hold on to that. You're going to do worksheet 3.8, but you're also going to do, I'm going to work a couple of these problems too, Lord willing, if I can pull it up. If not, it'll be alright. Looking for derivatives of inverses. Do you see that anywhere? Of course you don't. You're not here. Derivatives of inverses, multiple choice. This sheet. It's somewhere in your packet, Jimmy. I'm not sure if it's the very, very next one, or not. I may have accidentally skipped a page. Okay. Where did it go? Seriously, where did it? Did I click the wrong thing? Did I tell it to go to the clipboard? Yeah, I bet I did. New page. Okay. I'm getting a text. It's Travis. We'll talk later. It says let g of x equals x to the 5th plus 3x minus 2, and let g inverse denote the inverse of g. Find g inverse prime at 2. So, we set our equation equal to 2. We solve for x, and then we do 1 over the inverse at the new x value. So it'll be, let's see, solve, menu, algebra, and usually these you actually can use your solve feature on because it's just a polynomial. The only time you really can't use your solve feature is with a trig function, and sometimes it gets mad with logs and stuff too, but for these you can use it, it's not a big deal. Equals 2, comma, x, 1 again, coincidence. So it's 1 over 5x to the 4th plus 3 at 1. Please tell me this is not the exact same problem I just did. Okay, no, it's not good. So I plug it in, 1 over 5 times 1 to the 4th plus 3. So that's 1 over 8, which is B. Yay! Alright, that's where this video stops.